Okay, now we want to talk about a special kind of acceleration called centripetal acceleration. So you should be familiar with linear acceleration, which is going to cause something to go in a straight line. Now, this kind of acceleration is going to be present when something is rotating. It's not going to be the same thing as rotational acceleration. So if you've got a wheel here and this wheel is rotating like this, it could be accelerating as it's going around in a circle. So if it was accelerating in this direction, we would say that it has an angular acceleration of alpha. But that is not what we're talking about. So this is going to be an acceleration which is going to be going inward on the thing. So you're going to have an object here that's going to be traveling around on a circle, and it's going to have a certain linear speed v. So this is going to be the speed of a particle that's going around in a circle, and it has a linear speed v in meters per second. This is going to be the radius of the circle. And then as it goes around and around, it's going to produce an acceleration given by that formula there. So it's going to be an acceleration, and it will be in meters per second squared, but we put a C on there to indicate that it is centripetal acceleration. So you experience this force whenever you're in a car and the car makes a sharp, let's say, right-hand turn. So when you are in a car and it makes a sharp right-hand turn, you feel as though you're being thrown outwards. Okay, now that's not really what's happening. Okay, now what is happening is the car is turning because of the centripetal acceleration. Okay, so let's say that here's the car over here. Now this car wants to go, according to Newton's first law of motion, in a straight line. So this car wants to go in a straight line, but it's turning like this. And that's because the car is experiencing a force. And that force is going to be inward. So that's going to be the centripetal force caused by the centripetal acceleration. Now, what do you feel though? So you feel yourself being thrown outwards because of Newton's first law of motion, but you're going to feel the door, the side of the car, pushing against you. And so it makes it seem like there is some mysterious force that is throwing you outwards on this thing, but it's just really a reaction force to this one. So this force here is the real one. The centripetal force is the real force. Now the force that you feel when you make an impact with the car, because the car is turning, we have a name for that force, and that's going to be called the centrifugal force. But the centrifugal force is really just the reaction force to the centripetal force. So here's the formula for centripetal acceleration, and if you wanted to calculate the centripetal force, we're going to use Newton's second law. So Newton's second law said that force is equal to ma. So if you multiply your mass times that acceleration, then that would be the centripetal force that is acting on your body. So I want you to watch this little video, Geeking Out Forces on an Amusement Park Ride, on YouTube. Okay, so go ahead and watch that. I'll wait. Okay, did you see it? All right, hope you did, because it's pretty cool. So that you've got these people that are standing on the edge of that green cylinder. The green cylinder starts going around and around with a certain linear speed. And then you notice that that green thing has a certain radius. And so therefore the people inside of that amusement park ride are going to experience a centripetal force that is going to pin them against the wall. And that force can be so strong that it would keep them from sliding down the wall, and they could even drop the bottom out from underneath them, and they would remain pinned to the wall because of that centripetal force. Okay, let's just do a calculation. Now you notice the formula doesn't have a box around it. So that means that on the exam, don't worry about it. I just want you to know the concept of centripetal acceleration. But here's a sample question. What is the centripetal acceleration of the amusement park ride shown on the previous slide? So this one took a lot of estimation. So based on the height of the people in the video, the radius of the ride is approximately 24 feet, but that's not metric, so let's change it to 7.3 meters, approximately. The time it took for the ride to make one revolution was approximately 2.8 seconds. So once it got up to speed, I had a stopwatch and I was looking at how fast it was going around, and so its linear speed, it went around in about 2.8 seconds. So therefore its linear speed is linear distance divided by time, but the distance it goes is a circle. So it goes around in a complete circle, and you should know that the circumference, so SIR, so the circumference of a circle is going to be equal to 2 pi r, where r is the radius. And so that's the reason why instead of the letter r, I put 2 pi capital R. So that is the linear distance it goes around every time it makes a circle. And we know that the time was approximately 2.8 seconds, so now we know its speed. So the linear speed of the ride as it's going around in a circle is going to be 16.4 meters per second. So now we can take that speed and plug it into the formula for centripetal acceleration, and we can calculate what would be the acceleration acting on the people in the ride, and it would be 37 meters per second squared. And then once, if we knew what their mass was, we could multiply their mass times the centripetal acceleration, and then that would be the centripetal force that would be acting on them. So for this, don't worry about the mathematics, just know the concept of what centripetal acceleration is. All right, let's take a break, and when we come back, we're going to talk about what rotational inertia is.